Shujaat Mubarak. I hope that you people would be fine. And This lecture is, in fact, the continuity or in connection with my previous lectures, which were on one-way analysis of variance. So, in fact, in this lecture, we'll be discussing what is two-way analysis of variance and how is it performed using SPSS. Before moving forward, that what is two-way analysis of variance, let me just give you a brief overview that how we can differentiate one-way analysis of variance from the two-way analysis of variance and one-way multivariate analysis of variance, one-way MANOVA and two-way MANOVA. So you can see the slides. In the slides on the right, you can see that there's a I have written the number of tests: independent sample t-test, paired sample t-test, and all that. In front of them, you could see a column having named dependent variables and then independent variables, and then in front of that you could see the categories. So in fact, this table is explaining that for example, if we have the independent sample t-test, so how many dependent continuous variable does it require, how many independent categorical variable does it require, and how many categories it requires, or how many categories it can compare. So for example, for the independent sample t-test, it requires one dependent variable, that should be the continuous variable, and one independent variable, that should be the categorical variable. Let's see, for example, if we want to check the intelligence scores of the class, and we want to divide the students among the various ages. For example, we have the students having the age between 20 to 25 years, 25 to 30 years, and 30 to 35 years. Let's see, for example, so we have the three age groups, and we want to check the level of intelligence. So but in this particular case, there are the three age groups, so obviously we cannot apply the independent sample t-test. But if we have, for example, two age groups, male and female, that are our categorical variable, and we want to check that whether the intelligence or the level of intelligence of the male does differ from that of female, or females differ from the male, vice versa. So for that, we have to apply independent sample t-test. It means that it requires, if we have a one categorical independent variable and one continuous dependent variable, so we can apply independent sample t-test, and it can deal with only two categories, means male, female, X and Y, A, B. So if there are more than two categories, and the same is the case, so we have to go for the analysis of variance. Like for example, if we have a one independent variable, one dependent variable, but we have more than two categories of the independent variable, like I gave you the previous example, that we have the three groups in the class, the age between 20 to 25, 25 to 30, and 30 to 31. So A, B, C, three groups, and we want to check that whether the level of intelligence does differ by the across three age groups. So for that, we have to apply one-way analysis of variance, because one-way analysis of variance or one-way ANOVA can deal with one dependent variable, one independent variable with the three categories. So you could here see that if you have more than two categories, 2 plus n, so and one dependent variable and one independent, so you can apply one-way analysis of variance, right? So before moving forward, after the independent sample t-test, there's a paired sample t-test, which is used for the experimental purpose. Here we have the same group, right? But we have the time 1 and time 2. For example, we want to check that level of intelligence of the class, or level of knowledge of the class related to the maybe stats before taking a kind of a training and after taking a training, right? So the group is same, but group's data is being taken at time t1, and then there is an intervention, and then again the data of the same group is being taken at the time 2. So it means that our independent categorical variable is time t1 and t2, data from the time 1 and time 2, whereas the dependent variable is the same continuous variable. The data is our dependent variable. So this is so in the paired sample t-test we have one dependent variable and one independent variable, but that independent variable is the the time 1 and time 2. One-way analysis of variance, I have already told you that it deals with the one dependent variable and one independent, but your independent variable can have more than two categories. For example, if I want to check that whether the motivation of employees differ by the various organization locations, we have discussed so many times, or for example, if I check that the level of intelligence differs in the various Asian countries, like for example, if I take the data from the Pakistan, India, Bangladesh, China and all that, and I want to see that, and I have taken the data from each country about the intelligence, and I want to apply and check that the level of intelligence differs by country or not. So for that I have to apply one-way analysis of variance, right? But now sometimes we have a situation when we have more than one dependent variable. Like for example, I want to see that whether the productivity, motivation and consistency, three things, whether the productivity, motivation and consistency of employees of an organization differ by 5 different geographical locations or not. Like for example, if an organization have the 5 different locations, one is Karachi, Islamabad, Peshawar, Faisalabad, Quetta, let's see, and at each location they have a certain number of employees. They want to see that across these 5 employees, level of motivation, level of consistency and productivity, do these 3 things differ across the geographical location or not. So it means that there are the 3 dependent variables and 1 categorical independent variable which has the 5 categories, right? So in this particular case we can apply one-way multivariate analysis of variance, right? So you know that this one way is showing the number of independent variables. Like if once I am saying that one-way ANOVA, it means that one way means one independent variable. If I say two-way ANOVA, it means that it deals with the 2 independent variable. If I say three-way ANOVA, it has 3 independent variables, right? The same way, when I say one-way MANOVA, it means that there is a 1 independent variable. And once I'm saying one-way and MANOVA, multivariate analysis of variance, so it means 1 independent variable with the multiple dependent variables. So like after one-way MANOVA, you could see that there's a two-way ANOVA. Two-way, as I told you, that two-way means 2 independent variables, and ANOVA, analysis of variance, so it means that once you have the 1 dependent variable and 2 independent variables, so you deal with the two-way ANOVA. So instead of two-way ANOVA, if it would be two-way MANOVA, so it would mean that 2 independent variables and multiple dependent variables, right? So this one-way, two-way, three-way, this is representing the number of independent variables, and the second clause, which is ANOVA or MANOVA, this is showing the dependent variable. So if it's ANOVA simple, so it's showing the 1 dependent variable. If it's multi MANOVA, so it means that it's showing the multiple variables. So here the same way, having the same rule, three-way ANOVA, 3 independent variables, 1 dependent variable, right? Two-way MANOVA, 2 independent variables and multiple dependent variables. Three-way MANOVA, 3 independent variables and multiple dependent variables. And if we have more than 3 ways, so it's called the factorial ANOVA. Normally it's not possible to deal with the more than 3 or even 3-way MANOVA, then it becomes too much complicated. Anyway, so it was important before moving toward this explaining the two-way analysis of variance that we can differentiate between the various techniques. Once we'll be able to differentiate, then we will be able to apply the right kind of techniques for the data analysis. So now let's move toward the two-way analysis of variance. In fact, two-way analysis of variance, it's called a two-way between group analysis of variance. First you studied the one-way between group analysis of variance. It is extension of the one-way, so it means that now it's a two-way. It means that it has two independent variables, right? So it has two independent variables and one dependent variable. So that's why we are saying it's a two-way analysis of variance. And obviously, as these techniques in fact allow us to deal with or to analyze one group or one dependent variables with the help of the two independent variables. Like, let's say I just explain my point with one example. I take the same example here. Like we see that level of intelligence, like in this particular case, differs by age. There are three age groups, as you can see here: 18 to 29, 30 to 44, and 45 to onward. So level of, here we have taken the optimism, that how positive we think about the future. So in one way, by applying one way ANOVA, we have seen that level of optimism differ by age. It means that as the one age group which is 18 to 29 has different level of optimism as compared to the age group which is 30 to 44, or as compared to the group which is 45 or onward. So in the one-way analysis of variance, we saw that the level of optimism differs by age. And how does it differ? That as we get older, as we are moving from one age group to other age group, our level of optimism is increasing, right? If, for example, if we were in the 18 to 29, our level of optimism is low, and those who are in the age group of 45 onward, their level of optimism is high and statistically significant and high, right? So now we want to check that further, if we divide the age groups into male and female, like whether the male in the age group of 18 to 29s have different level of optimism as compared to the female in the same group, right? So is it possible to see? So this two-way analysis of variance in fact tells us, it in fact helps us to just look into the data to see that first we have divided the data into one group, and then again that group can be divided into a subgroup on the basis of the second variable. So now, for example, we have a question, as you can see that highlighted in red. The next question we can ask is this case for the both males and females, that whether the same is applied if data is divided into male and female, or it's not the case. That, for example, I can say that okay, 18 to 29's age group is different than the 45's age group, but only males are different. Females or level of optimism is same as compared to the 45 years old people group. So for that, it means that now I have to check data from two perspectives. I have to divide the data into the age group and then into the gender. So this two-way analysis of variance really helps us. This discussion in fact leads us to draw the question that how many number of variables are required for the analysis of for two analysis of variance. So obviously we require two independent variable, and there should be a one dependent variable in order to apply two analysis of variance. So in the next slide I'll be just telling you that how to apply it. I'll be a bit quick because this video would be recorded, so you can stop and you can check that how you can apply with the help of SPSS. Anyway, I'm just giving you a brief summary that what kind of research question it deals with. Does level of optimism differ by age and gender? Previously we were checking does level of optimism differ by age. Now within the age by gender. So 16 years male and 16 years female, right? The A group, male, female, whether do they differ or not? Does level of optimism differ? Or we can put it in another way. Does level of optimism differ in interaction of age and gender, or does gender moderate the relationship between age and optimism? Interaction means that gender and age together, we are creating another group. Like as I told you that with the help of age, that we have a three age group, so we have divided data into three age groups, A, B, C. Now once we plug in gender, so we divide that data, three groups data, into further three more groups. So now it becomes six groups. For example, A is young, B is you can say okay, youth, and C is the older people, right? So now what we have youth male and youth female. We have young male and young female, youth male and youth female, and we have older male and older female. So the data has been further divided into on the basis of the gender. So we want to compare that whether the youth male and female, they have the same level of optimism or not, whether the young male and female have the level of optimism same or not, and the older level of optimism they have same or not, right? So these are the kind of research question it deals with. It requires two categorical independent variables. I've already told you it requires one continuous dependent variable, and how it does, I have already explained you that. It's for the detail you can just read more this slide. Okay, moving on. For this particular survey we have used the data. In fact, we have taken the data from the online source. I'm trying to remember, but it's a Julian or something from his website. We have taken the data, and the same data we are using. The data, the variable's name is top TIM. It shows the total optimism, and these are the total optimism score. This is our dependent variable. Our first independent variable is AGP, age group, divided into three. First group is 18 to 29, second group is 30 to 44, and third group is 45 plus onward. And the second independent variable is male and female. So these two are our independent variable, and this one is our dependent variable. So moving forward, this is the procedure for applying two-way analysis of variance. This procedure means that by following these footsteps you can go to your SPSS, and by following this each step you can run to the two-way analysis of variance. I just wanted to run myself. Let's see, I try if this software helps me to do so. Particular window appears, and here in this window you have to just move your dependent variable. So in our case, our dependent variable is total optimism. We have moved here, which is continuous as shown here, and then both of the independent variable we have clicked, and then we have dragged them or moved here in the fixed factors, right? After that we click on the options button. After clicking option button, this window appears. We click on the descriptive stats, estimates effect size and homogeneity of the variance, and then we click on continue, and afterwards we go to the group number 2, which is here we click on the post hoc test. Here you can just see. So once you are done with that, so you have to next click this post hoc test. So this post hoc test, once you have clicked, you could see that basically this age group 3 would be here. So you have to click on the age group 3 from this, and then you drag and move it to the post hoc test 4. So again I repeat, once you will be clicking the post hoc, the age group 3 would be appearing here, and after that you have to move it over there, right? You have to drag it, and you have to move it to this particular section, which is post hoc test, and then you click OK. In fact I have to be a bit fast because the battery of my laptop is getting out, and I don't have my charger here. So moving forward, okay, then you once you're done with that, then you click again, I come here, then you click on the plot, right? So once you click on the plot, it will be coming here. So once we have the two independent variables, so the variable which has the highest groups we put on the horizontal axis, and the variable which has the lesser groups we put on the here on the separate lines. So we do the same thing. We click on age group 3 and we drag it to the horizontal axis. We put on click here on the gender, and then we drag it to the separate lines, and then we go to the continue, then we click OK. So there will be a lot of results would be appearing in front of you. These results I have arranged these results here in the sequence of explaining it. Now let's go to the explanation of the results. I have already told you that those who are my students are those to whom I interact with really. Once we discuss about the explanation of the results, that we should follow the format that is DDM. That first we explain the descriptive stats or the demography of the data whenever we are explaining the results. After explaining that, we move toward the second step, that's the diagnostic test. the test which in fact test which shows or which show us the suitability of the data, that how much data is fit for applying the test which we are applying on the data, and then we move toward the M for the main findings. So we have again distributed the results of two-way analysis of variance in the same categories. The first is the, you can see the upper table, dependent variables total optimism. It's showing the descriptive stats. It's showing the various age groups, and then their means and standard deviation number. For example, we can see that in the age group of 18 to 29, males and female, males mean is 21.38, females mean score is 21.34, and number of males 60 and number of females 87, and you can just see the rest of the groups. Okay, so this is this descriptive strategy. We can explain this while explaining the results. Then we come toward the second D, which is a diagnostic test. In the two-way analysis of variance, the only diagnostic test is Levene's test for equality of the variances, and I've already, perhaps in some of the last lectures I have discussed with you, and that this insignificant value of the Levene's test shows that our data assumes the equal variance, right? So if the Levene's test value is significant, it means that our data does not have the homogeneity of the variance, or our data does not assume the equal variance. In our case, the Levene's test value is insignificant, which is 0.369, which is obviously greater than 0.05. It shows that our data assumes equality of error variance. Okay, so now let's move forward. So if for diagnostic test is okay, then we can go toward the main findings. So main findings here, in this particular case, the main findings are, in any case, while applying two-way ANOVA, we have to look for the table which is showing test of between subjects effect. Now you see that in this table I have highlighted in red age group, asterisk, sex or gender. So this is in fact showing the interaction effect, and above that you can see sex or gender, and then you could see age group. So we conventionally we have the significant values. With the help of that we can see that whether there is a difference or not. So let's see from starting from the age group. Age GP3, it's degree of freedom 2. You can just see here the F value is 3.911, and significant value or the P value is 0.021. It is showing the 0.021 is less than 0.045. It's showing that the level of optimism does differ across age groups. So it's reinforcing the findings of the previous one-way analysis of variance. But our aim is to check that whether does it differ further within the group, within that. For example, okay, it is okay that it's differing by age, but within that age group, if further we divide that group into two and then compare, so does it differ or not? So for that we have to go to this interaction variable which have been highlighted in red, age group multiplied by sex or gender. It is showing that each age group has been divided into two, male and female. So here value is 0.237. It is showing that if we subdivide the data which have been already divided into age groups, if we further divide it into male and female, so level of optimism does not differ by male and female. So, and even we can just see that even overall level of optimism differ by gender, like taking all of the data, does level of optimism differ by gender or not? So we can just see that here, this in front of the sex, you can just see the significant value is 0.586. So this is also showing that even if we divide whole of the data into two groups, these are male and these are female, so even there is no difference between the level of optimism between male and female, right? And there is also no level of optimism once we subdivide the age group into male and female. So it is showing the no interaction effect of the gender in the relationship between age group and level of optimism. So then if we, for further clarification, if there would be some difference, so definitely we could have used the comparison test, which is key HST test for the further comparison, but for a bit more detail, we can just look into this multiple comparisons test, which is comparing the data of the age groups with each other. For example, here we can just see that age group of 18 to 29, while comparing 30 to 44 has the mean difference of minus 0.74, but value is insignificant. It means that age group of young and youth, they do not differ significantly in terms of their level of optimism. And then once we compare this young people with again the older people, so we can see here the level 0.007 value, which is obviously lesser than 0.05, and mean difference is minus 1.60. So it's showing that the level of optimism differ by the older, and between the level of optimism is different in the older as compared to the younger people. So, and the minus sign is showing that as we are moving from the younger age group to the older age group, so level of optimism is increasing. So it's showing that level of optimism is higher in the older people, but it does not show any evidence that once we divide the age group further into the male and female, so there's no any difference in the level of optimism. And then eta square is showing further that how much, so the value of the eta square, which has 0.018, even in the age group, it's showing that although the various groups differ across each other, but the effect size or the magnitude of the difference is not so much, or it's not very big. So this is how we can perform the two-way analysis of variance. This is a kind of you can say a recommended way to present the results of two-way analysis of variance. Nevertheless, this is not the only way. You can present the results in your own way, but while presenting the results, remember that you have to always first you should apply the descriptive stats, and once you have gone for the descriptive stats, then after descriptive stats you can explain the diagnostic test, and once you have explained the diagnostic test, then you can go for the main findings. Thank you very much.